The 1990 Hubble Space Telescope Flaw. This event not only highlighted the challenges of space engineering, but also showcased the incredible problem-solving capabilities of the scientific community. The Hubble Space Telescope was a groundbreaking project that promised unprecedented views of the universe. However, a critical flaw in its primary mirror nearly jeopardized the entire mission. Understanding this event gives us insight into the meticulous nature of space missions and the perseverance required to overcome setbacks. The Hubble Space Telescope's story is not just about a piece of hardware. It's a narrative of human ingenuity, determination, and the relentless pursuit of knowledge. Let's explore this fascinating chapter in space exploration. Development and expectations. The Hubble Space Telescope, named after the renowned astronomer Edwin Hubble, was developed by NASA with significant contributions from the European Space Agency. The telescope represented a quantum leap in our ability to observe the cosmos. With a primary mirror 2.4 meters in diameter, Hubble was designed to capture images of unprecedented clarity by operating above the Earth's atmosphere, which distorts and blocks the light that reaches ground-based telescopes. The project began in the 1970s with an initial budget of around $400 million. But due to various delays and technical challenges, the cost eventually ballooned to $2.5 billion by the time of its launch. Despite these hurdles, the scientific community was highly optimistic about the potential discoveries Hubble could facilitate. The telescope was expected to revolutionize our understanding of the universe, from the formation of stars and galaxies to the fundamental properties of the cosmos itself. Initial triumph and subsequent disappointment. The Hubble Space Telescope was launched on April 24, 1990, aboard the Space Shuttle Discovery. The launch itself was a significant achievement, marking the culmination of decades of planning, development, and testing. The deployment of the telescope into its orbit, approximately 547 kilometers above Earth's surface, was executed flawlessly, and the scientific community eagerly awaited the first images from Hubble. However, excitement soon turned to disappointment when the initial images were received. Instead of the sharp, detailed images that were expected, the pictures were blurry and out of focus. This was a devastating blow to NASA and the international astronomical community. The blurry images indicated that there was a serious problem with the telescope's optics, a problem that threatened to undermine one of the most ambitious scientific endeavors of the 20th century. Nature of the flaw. The primary mirror of the Hubble Space Telescope had a spherical aberration. This meant that the mirror was not perfectly shaped to bring all incoming light to a precise focus. Specifically, the edge of the mirror was too flat by just 2.2 microns, about 1/50th the width of a human hair. Despite this seemingly tiny error, the impact on the telescope's performance was enormous, causing light to be focused incorrectly and resulting in blurry images. The primary mirror's job was to collect light from distant celestial objects and reflect it to a secondary mirror, which would then direct the light into the telescope's scientific instruments. The spherical aberration caused the light from the outer parts of the mirror to converge at a slightly different point than the light from the center, leading to the blurred images. The root cause of this flaw was traced back to a manufacturing error during the polishing process of the mirror. The mirror had been ground to an incorrect shape due to a flaw in the testing equipment used during its fabrication. This equipment, known as a null corrector, was designed to ensure that the mirror had the perfect curvature. However, a miscalibration in the null corrector led to the mirror being polished incorrectly. Perkin-Elmer Corporation, the contractor responsible for the mirror's fabrication, had used this faulty equipment, and the error went unnoticed due to a combination of procedural issues and oversight failures. Additionally, the independent verification processes failed to detect the flaw, leading to the flawed mirror being installed in the telescope. The discovery of this flaw was a huge blow to NASA. The space agency faced intense public and media scrutiny, as well as criticism from the scientific community. The initial reaction was one of shock and disbelief, followed by a period of intense investigation to determine the cause and extent of the problem. The mission's credibility was at stake, and there was significant pressure to find a solution. The spherical aberration significantly compromised the telescope's ability to fulfill its scientific objectives. Without a correction, the Hubble Space Telescope would be unable to produce the high-resolution images that were critical for a wide range of astronomical studies. This situation demanded an immediate and effective response from NASA: diagnosis and planning. Once the problem was identified, NASA and its engineers undertook extensive ground-based analysis to fully understand the extent of the issue. Teams of scientists and engineers worked around the clock to analyze the data and devise a plan to correct the flaw. The challenge was not only to diagnose the flaw, but also to devise a solution that could be implemented in space, hundreds of kilometers above the Earth. One of the primary approaches considered was to develop corrective optics that could compensate for the flawed mirror. This involved designing and manufacturing new optical components that could be installed on the telescope during a servicing mission. The idea was to use these corrective optics to refocus the light and eliminate the spherical aberration. The servicing mission, 1993. In December 1993, NASA launched the first servicing mission, STS-61, to fix the Hubble's mirror. The mission was carried out by the Space Shuttle Endeavour, and the crew included 7 astronauts specially trained for the complex repair tasks ahead. This mission involved a series of spacewalks to install the Corrective Optics Space Telescope Axial Replacement, COSTAR, and new instruments equipped with corrective optics. The COSTAR system was designed to correct the flawed images by introducing a set of small mirrors that would compensate for the spherical aberration. Additionally, the Wide Field and Planetary Camera 2, WFPC-2, which had its own corrective optics, was installed to replace the original camera. The astronauts' work during this mission was incredibly challenging. They performed 5 spacewalks, each lasting several hours, to install the new equipment. These spacewalks required precise coordination and execution, as the astronauts had to work in the vacuum of space, handling delicate instruments and tools while tethered to the shuttle. The successful installation of the corrective optics was a testament to NASA's ingenuity and the astronauts' skill. This mission turned what could have been a catastrophic failure into a resounding success, showcasing the space agency's ability to solve unprecedented problems in space. The entire operation was a remarkable achievement in space engineering and demonstrated the importance of human intervention in space missions. Post-correction achievements. Following the successful servicing mission, the Hubble Space Telescope began sending back stunning images of the universe. One of the most famous is the Pillars of Creation in the Eagle Nebula. These images not only captivated the public, but also provided invaluable data for scientists. The clarity and detail of the images exceeded expectations and reaffirmed Hubble's status as a premier astronomical tool. The corrected Hubble provided stunning images of the universe, including views of galaxies, nebulae, and other celestial objects in unprecedented detail. These images have been critical in numerous scientific discoveries, from understanding the life cycles of stars to exploring the structure of galaxies. Hubble's ongoing contributions. Over the years, Hubble has undergone multiple servicing missions, each time being upgraded and repaired to extend its operational life. These missions have included the installation of new instruments, replacement of aging components, and enhancements to its scientific capabilities. Hubble's longevity and continued productivity are a testament to the robust design and successful maintenance efforts by NASA. Hubble has provided critical data that has led to numerous discoveries, including the rate of expansion of the universe and insights into the formation of galaxies. Its observations have contributed to our understanding of dark energy, dark matter, and the fundamental processes that govern the cosmos. Hubble's impact on astronomy is profound, influencing countless studies and inspiring a new generation of astronomers. The idea for a space-based telescope was first proposed in the 1920s by German scientist Hermann Oberth. However, it wasn't until the 1970s that technology and funding began to converge to make such a dream feasible. The concept was driven by the limitations of ground-based telescopes, which suffer from atmospheric distortion. The Hubble Space Telescope was designed to operate above the atmosphere, providing clear, unobstructed views of the cosmos. The development of Hubble was a monumental task involving thousands of scientists, engineers, and technicians over several decades. The project's ambitious goal was to unlock mysteries of the universe, including the formation of stars and galaxies, the existence of black holes, and the expansion rate of the universe. Upon discovering the flaw, NASA conducted a thorough investigation to understand how such an error could have occurred. The null corrector, a critical piece of testing equipment, was found to have been assembled incorrectly, which led to the mirror being polished to the wrong shape. This error went undetected because Perkin-Elmer Corporation, the contractor responsible for the mirror, did not adequately cross-check the results with independent tests. This oversight was compounded by a lack of thorough communication and documentation practices, which could have identified the discrepancy earlier. The flawed mirror was a significant setback not just for NASA, but for the entire astronomical community. There was considerable embarrassment and frustration among scientists and engineers who had devoted years to the project. The media coverage was intense and often critical, questioning NASA's competence and the justification of the substantial public investment in the project. This period was marked by a crisis of confidence within NASA and among its stakeholders, prompting a reevaluation of processes and a renewed commitment to excellence. Planning the servicing mission to correct Hubble's flaw was a complex endeavor. The mission required the development of new tools and procedures for astronauts to use in space. Training for the astronauts was rigorous, involving simulations of the spacewalks in underwater tanks to mimic the microgravity environment of space. The precision required for the installation of corrective optics was immense, as even a minor error could have resulted in the mission's failure. The spacewalks involved working with small, delicate instruments while wearing bulky spacesuits, adding to the complexity of the task. After the successful correction of Hubble's optics, the telescope began to fulfill its promise, providing stunning images and valuable data. One of the earliest triumphs was the confirmation of black holes at the centers of galaxies, a hypothesis that had been difficult to prove with ground-based observations. Hubble also played a crucial role in measuring the rate of expansion of the universe, contributing to the discovery of dark energy, a mysterious force that accelerates the expansion of the cosmos. These and other discoveries have reshaped our understanding of the universe and have opened new avenues for research. The success of the initial servicing mission led to additional missions aimed at maintaining and upgrading Hubble. Each servicing mission brought new technology and capabilities to the telescope, ensuring it remained at the cutting edge of astronomical research. These missions included the installation of advanced cameras and spectrographs, enhancements to its power systems, and repairs to its gyroscopes, which are critical for pointing the telescope accurately. The ability to continually upgrade Hubble has allowed it to produce groundbreaking science for over 3 decades. If you found this video informative, please like, comment, and subscribe. Also, share your experiences if you have witnessed any similar scientific achievements or setbacks. Share your thoughts in the comments on what you think about the significant achievements of the Hubble Space Telescope. Thank you for watching.